Welcome to educational channel of sureshbhattclasses. We are going to discuss NCERT class 10th chapter 1 real numbers topic 1.5 revisiting rational numbers and their decimal expansions. We know that rational numbers are of the form p upon q where q is not equal to 0 and p and q are co-primes. Rational numbers are either terminating decimals or non-terminating recurring decimals. Theorem: let x be a rational number with terminating decimal expansion, then x equal to p upon q where q is not equal to 0 and p and q are co-primes, and q on prime factorization is of the form 2 to the power m or 5 to the power n or 2 to the power m into 5 to the power n, where m and n are non-negative integers. This we will learn from some examples, and we proceed like this. Example 1, 0.375 equal to, if we convert this decimal into rational form, then this becomes 375 upon 10 to the power 3. As there are 3 digits after the decimal, so the denominator is of the form 10 to the power 3. We put 1 for decimal and 3 zeros for the 3 digits. This can be written as 3 multiplied by 5 to the power 3 upon 2 to the power 3 into 5 to the power 3. This gives us 3 upon 2 to the power 3. Here, when we are getting the denominator as 2 to the power 3, then our decimal expansion of this rational number is a terminating decimal. Here this is important that the denominator on prime factorization gives us 2 to the power 3 or 2 to the power m in general. We go to another example, 0.112. This is on writing as rational number gives us 112, 0.112 or 0.112 equal to 112 upon 10 to the power 3. Again we put 1 for the decimal and 3 digits for the 3 zeros for the 3 digits. This gives us 112 upon 10 to the power 3. This gives us 7 multiplied by 2 to the power 4 upon 2 to the power 3 into 5 to the power 3. This gives us 14 upon 5 to the power 3. Here we find that the denominator on prime factorization is of the form 5 to the power n, where n is non-negative. We go to the third example, 25.366. This we write as rational number, then this becomes 25,366 upon 10 to the power 3. We again put 1 for the decimal and 3 zeros for the 3 digits after the decimal. So this gives us 25,366 upon 10 to the power 3. Now we factorize it. So we get 12,683 multiplied by 2 divided by 2 to the power 3 into 5 to the power 3. This gives us 12,683 upon 2 to the power 2 into 5 to the power 3. Here on prime factorization of denominator and solving it, we get 2 to the power 2 and 5 to the power 3, or 2 to the power m into 5 to the power n, where m and n are non-negative integers. Thus we observe that denominator is always of the form 2 to the power m or 5 to the power n or 2 to the power m into 5 to the power n, where m and n are non-negative integers for terminating decimal expansion of rational numbers. Thus, what we see that when we have to have the terminating decimal expansion of rational number, the denominator must be of the form 2 to the power m or 5 to the power n or 2 to the power m into 5 to the power n. We go to the next theorem, which is converse of the above theorem, which states that let x be a rational number, that is x equal to p upon q, where q is not equal to 0, such that prime factorization of denominator q is of the form 2 to the power m into 5 to the power n, where m and n are non-negative integers. Then x has terminating decimal expansion. We learn it by some examples. Example 1, 75 upon 2 to the power 3, which we can write 75 multiplied by 5 to the power 3 upon 2 to the power 3 into 5 to the power 3. We have multiplied the numerator and denominator by 5 to the power 3, as we were having 2 to the power 3, so we multiplied it by 5 to the power 3 to get it as 10 to the power 3. So this gives us 75 multiplied by 125 upon 10 to the power 3. This is equal to 9375 upon 10 to the power 3, which is equal to 9.375. Thus, when the denominator is of the form 2 to the power m into 5 to the power n, then we get the terminating decimal. We go to the next example, 82 upon 5 to the power 2. We write it as 82 multiplied by 2 to the power 2 upon 2 to the power 2 multiplied by 5 to the power 2. We have multiplied numerator and denominator by 2 to the power 2, so that we can get the denominator as 2 to the power 2 into 5 to the power 2, which makes 10 to the power 2. This is equal to 82 multiplied by 4 upon 10 to the power 2. This is equal to 328 upon 10 to the power 2, equal to 3.28. Thus, when the denominator is of the form 5 to the power n, which can be converted into 2 to the power m into 2 to the power n, then we get the terminating decimal. We go to the third example, 475 upon 2 to the power 2 into 5 to the power 3. Now we have to make it into the denominator into 10 to the power 3. What we will do, we will multiply numerator and denominator by 2 to the power 2. We will multiply numerator and denominator by 2 to the power 1. So we get 475 multiplied by 2 upon 2 to the power 3 into 5 to the power 3. This gives us 950 upon 10 to the power 3. This is equal to 95 upon 10 to the power 2. This is equal to 0.95. Thus, when the denominator is of the form 2 to the power m into 5 to the power n, we get the terminating decimal expansion of rational number. Next theorem, which states that let x be a rational number, that is x equal to p upon q, where q is not equal to 0, and p and q are co-primes, such that prime factorization of q is not of the form 2 to the power m into 5 to the power n, where m and n are non-negative integers, then x has a decimal expansion which is non-terminating recurring. That is, when the denominator is not of the form of 2 to the power m into 5 to the power n, then the decimal expansion of rational number is non-terminating recurring. We'll learn it by some examples. Our first example is 4 divided by 3 or 4 upon 3. Here denominator is not of the form here the denominator is not of the form 2 to the power m into 5 to the power n. It is other than 2 and 5, which is 3. Then we get the decimal expansion as 1.3333, this goes on, which is equal to 1.3 bar. Our next example is 1 upon 7. This is equal to 0.142857. Again 142,857, and this continues and this repeats itself, which is equal to, this is equal to 0.142857 bar. Our third example is 1 upon 11. This is again not of the form 2 to the power m into 5 to the power n. That is, the denominator is not the product of 2 or 5. Then we get 1 upon 11 as 0.0909. This continues, which is equal to 0.09 bar. This is non-terminating recurring decimals. Here completes this video. Please like, share and subscribe to this channel. Also press the bell icon to get the latest notifications.